So here we have an example where we will use the pocketing function for this ANSI job. So this is our pocket, so let's select the outer contour, which we now selected, and as this is our first element, if we do a finishing, it will start here. So let's move to ANSI jobs pocketing, and we'll just follow the dialog and answer the questions which will lead to the ANSI program, so you can't really get wrong by just answering the questions. Okay. Machine with the finishing, yes, we would like a finish. Okay. Tensor will give you some information about the maximum tool diameter you may use to pocket this, and you would at least need a 6mm tool to finish it, because the smallest radius in this contour is the 3 right here in the corner. So we might want to select a tool of about 16mm. Okay. Would you like to load a new tool? Yes, we will. And this will lead to the tool library, and in the tool library you will see a number of tools you can select. So we could, for example, select the flat end of 16 for the roughing part, and we will select this, and as we selected our tool, it will ask some questions about the tool. In this case we will use the Heidenhain post processor, and we will get a Heidenhain program. Of course you can also generate this for every easy controller you would like to. Okay, so the depth of our pocket is 5mm, and we'll do this in one step. The start value is 0 of my part, and the step is 5. The last step, we could do a finishing, but in this case we'll just do it in one time, and we'll have allowance on a profile because we would like to finish the profile, and we will take a 60% overlap of our tool diameter. Okay. We can select a strategy, either zigzag or spiral. I think we will select the spiral in this case. Okay. And as there are no islands in my pocket, we can just select the Z level, which in this case wouldn't really make a difference. Okay. We can select either per step or helical. Well, in this case we'll select per step. The start height, the retract height, and there's our first tool path. Tensor now will recognize that we have some material left because we used a big tool of 16mm, and this means we couldn't reach the corners. So if we want to, we can do an NC job for the remaining stock material. We will answer yes. Okay. And don't select a tool bigger than 5.6, which is actually the radius of 3 times 2 is 6 minus the allowance of 0.2, which will leave you 5.6. And we will select a tool smaller than 5.6. Let's in this case select the flat end of 4. Okay. Okay. And okay, and we'll do this in one step as well, and we'll leave the 0.2 allowance on our profile, and we'll select a 60% overlap, and the retract height, approach height will leave the same. And there you can see our green tool path, which is our stock rest material path. And now Tensor will ask you to finish the profile. Okay. Use tool composition, yes, we will. Would you like a new tool? Well, I think in this case we don't need a new tool, so we'll answer no. Tensor will present the spindle speed, feed rate, everything. So if you want to, you can adjust these values. Okay. And enter these values. Allowance 0. Okay. You can see a lot of same questions every time, so this should make it a little bit easier for you to work with Tensor. Yes, we will use an approach which will be generated right here, as this is the first line of our profile, and we can convert this into NC code. We wouldn't like any copies, no. So, and there's our program. So you can see you just get a dialog presented and you just answer the questions, and this will result into this NC program. So if you would like to see how it looks like, you can hit the I button and move to the Tensor Simulator and click on the I button, and there's your part, and you can start the simulation. So there's your tool 16 doing the roughing, and there's your tool 4, which is now removing the stock material, and it will also do the finishing. So there's your finishing, and there's your pocket, and the machining time in this case would be 22 minutes using these spindle speeds and feed. So let's move on to the next example.